Hi everyone, welcome to the second week of Math CEO. And today we're going to talk about the game of confidence. Now, a lot of you must already be familiar with this game because, in common parlance, it's called the prisoner's dilemma, and it's a very famous game that shows up everywhere in economics, in philosophy, political science, etc. But for our kids, we're going to call it the game of confidence. And let me first walk you through the basic structure of this game. It's a two-player game, and each player has two options, so two possible moves. And the moves are they can either cooperate or they can cheat. Okay, so what happens when they play these moves? So there are four possibilities, right? Either they could both cooperate, they could both cheat, or player one could cooperate, player two could cheat, or player one could cheat and player two could cooperate. What are the outcomes in each of these possibilities? You can see this matrix that I've drawn in game theory. This is called a payoff diagram. Payoff means sort of the points or the outcome that results from a particular gameplay. And a payoff diagram is just a matrix or like just an array of numbers that summarizes all the possible payoffs that can arise from all possible moves by the different players. Okay, so this is what happens. If both cooperate, then each of them gets 2 points. If player one cooperates and player two cheats, then player one gets 3 points and player two loses a point. The same if the roles are reversed. And if both cheat, then neither gets anything. So both get 0 points. Okay. So now that you know the basic structure of this game, how would you introduce it to the kids? It's a bit boring to introduce the game in terms of just, oh, there are these two options and there's this payoff matrix, etc., etc. This game can be introduced in many different ways, and I would encourage you to try to come up with your own story, setting, context through which to introduce this game. Now, the teaching guide gives you, or the student workbook gives you one way to do this, and that is through this coin machine. So, suppose there's this machine such that if I put in a coin in that machine, one coin is turned into 3 coins for my friend. So there's me and my friend Akriti. We find this machine, and if I put in one coin, then Akriti gets three. If Akriti puts in one coin, then I get three. Now, cooperation in this context would mean putting in one coin. Okay. And cheating would mean not putting in anything. Okay. So now what happens? If both Akriti and I decide to put in one coin each, then we each lose a coin, but each of us also gains 3 coins because Akriti's one coin is converted into three for me. So three minus one plus three is two. And the same for Akriti. If both of us cheat, that is, neither of us puts any coin, then nothing happens. The machine doesn't do anything and we don't lose anything either. But now, if I decide to put one coin and Akriti decides to put nothing, that is, if I cooperate and Akriti cheats, then she gets 3 coins without losing anything because my one coin gets converted into three for her. But I gain nothing, and in fact, I lose the original coin that I put into the machine. Right? So, this is a good way, or one of the many ways, to model this game. And I would suggest trying to come up with some kind of way to introduce it to the kids. That is not just in terms of this kind of abstract cooperate or cheat kind of language. Okay, so now let's focus our attention to what actually is going on in this game. Like, why is it so popular? The reason it's so popular is because each player has an incentive to cheat in every situation. So actually, if both parties are behaving in a selfish way, and by selfish, I mean they only care about their own individual payoff or their own individual gain from this game, then actually both of them will end up cheating, and the outcome will be um, 0-0. Why is that? Let's go case by case. Suppose I'm player one. Okay. Now, if player two decides to cooperate, then what is my best strategy? Well, if player two cooperates and I cooperate, I gain 2 points. And if player two cooperates and I cheat, then I get 3 points. So, in fact, if player two cooperates, then my best strategy is to cheat if I want to maximize my gain. And if player two cheats, then if I cooperate, I lose a point. And if I cheat, then nothing happens. I don't gain, but I don't lose either. So if player two is cheating, then my best strategy is to cheat, and the outcome would be 0-0. So regardless of what player two does, if I want to maximize my gain in each situation, I should cheat. And the same symmetric reasoning applies to the other player as well. So they want to cheat as well, and therefore the outcome that everyone ends up with is 0-0, which is actually a bad outcome, right? Because if both were to cooperate, then both would gain 2. I mean, sure, 2 is not as good as 3, but it's certainly much better than 0. So this game is famous because it like highlights a situation that occurs very frequently in our daily lives. Um, there are many situations in which if we want to act selfishly, and by that I mean if we want to just like maximize our individual gain, if each party sort of does that without thinking about the collective good, then everyone ends up with the worst outcome. Whereas if we were to cooperate, then everyone would end up with a better outcome. The issue is that it is difficult to bring about cooperation because it requires some risk and it requires trusting the other person, right? If I cooperate, but the other person ends up cheating, then I actually lose a lot. So there is some risk to cooperating. And if I trust player two, if player two is my friend, perhaps, or if player two has like a reputation of, being has a reputation of cooperating, then those would be reasons for me to then also cooperate. But if I lack that information, then I might want to cheat to because I don't want to take the risk. And you can imagine that when thinking about, say, different countries making trade deals, or maybe different businesses deciding whether they want to do business with each other. These are all kind of situations in which this kind of reasoning would be relevant. Okay, we'll talk more about this game and the different ways in which you can play this with the kids in the next video.